Good morning, students. Today we will begin our third lecture. We will try to solve numericals as the homework part which we had given in the previous lecture. So the previous lecture problem: a square have a side 120 mm. Calculate its MI about the vertical centroidal axis. Vertical centroidal axis is I by y. The side given is 120 mm and Ixx is equal to bd cube by 12. Iyy is equal to db cube by 12. Ixx is equal to 120 into 120 cube divided by 12, which is equal to 1.728 into 10 raised to 4. Iyy is equal to db cube by 12, which is equal to 120 into 120 cube divided by 12, which is equal to 1.728 to 10 raised to 7 mm raised to 4. So here both Ixx and Iyy are the same as it is square. Okay. So next slide please. The next problem is determine moment of inertia for equilateral triangle of side 400 mm. Equilateral triangle, 3 side equal, b is equal to 400. Formula Ixx is equal to bh cube divided by 36. Iyy is equal to hb cube by 36. Now we have to first find out h over here. H is not given, so sine 60 is equal to h divided by b. H is equal to b sine 60. H is equal to 400 sine of 60. H is equal to 346.41 mm. Ixx is equal to 400 into 346.41 whole cube divided by 36. So Ixx is equal to 4.61 into 10 raised to 8 mm raised to 4. Next we have to find Iyy is equal to hb cube divided by 48. H is 346.41 into 400 cube divided by 48. Iyy is equal to 4.6 into 10 raised to 8 mm raised to 4. So Ixx is equal to Iyy. In this problem, Ixx is equal to Iyy. Next slide. Now we'll come to the type 2 or type B type of problem, in which we have to find out the radius of gyration and the polar moment of inertia. As I earlier mentioned, in between I will repeat the theory so as to make problem more relevant to you. Now radius of gyration k is the distance at which the area is supposed to be concentrated to give the same moment of inertia. I is equal to a k square. K is equal to under root I divided by a. Similarly, kxx is equal to under root Ixx divided by a. Similarly, kyy is equal to under root Iyy divided by a. Now here it's something like where the mass or where the whole area is concentrated. Okay, so as to get that moment of inertia, so as to get that resistance. So where there is more area, more mass, obviously it will try to resist bending moment. Fine. Next slide. where I is equal to moment of inertia about the axis considered, A area of section, K radius of gyration about axis considered. Unit of K is millimeter, centimeter and meter. Type B problem. Here we have to find polar moment of inertia and minimum radius of gyration. So the first problem here, calculate polar moment of inertia of some semicircle having 60 mm diameter. Also calculate minimum radius of gyration. The diameter is parallel to y-axis. Now please note that sometimes the diagram would be given, sometimes it won't be given. So you have to draw it on your own. They gave the hint that the diameter is parallel to y-axis. So the base has to be vertical. So that is how we get this diagram. The base is vertical and we have a semicircle. D is equal to 60, R is equal to 30. First we have to find Ixx. Ixx is equal to pi r raised to 4 divided by 8. Ixx is equal to pi into 30 raised to 4 divided by 8, which is equal to 318.08 into 10 raised to 3 mm raised to 4. 10 raised to 3, I repeat, 318.08 into 10 raised to 3 mm raised to 4. Next slide. Yes, in previous slide we calculate Ixx, and in this slide we will calculate Iyy. Iyy is equal to 0.11 r raised to 4. Iyy is equal to 0.1 into 30 raised to 4. Iyy is equal to 89.1 into 10 raised to 3 mm raised to 4. Now polar moment Mi is equal to Izz is equal to Ip. Izz is equal to Ixx plus Iyy. So we are adding Ixx, that is 318.08 into 10 raised to 3 plus 89.1 into 10 raised to 3. We get Izz is equal to 407.18 into 10 raised to 3 mm raised to 4. So this is Izz. Now next we have to find minimum radius of gyration about the centroidal axis. Minimum radius of gyration about centroidal axis, Kxx and Kyy. Next slide. Now to calculate minimum radius of gyration, A is required, that is area of circular lamina, which is equal to pi r square divided by 2, that is equal to pi into 30 square divided by 2. We get 1413.71. Now we have find out Ixx and Iyy. Now Iyy is minimum, that is 89.1 into 10 raised to 3. Therefore K minimum would be equal to Kyy equal to under root I minimum divided by A, which is equal to under root 89.1 into 10 raised to 3 divided by 1413.7 equal to 7.938. K minimum is equal to 7.94. I hope it is clear to you. Next slide. Next problem, determine polar moment of inertia of hollow circular section of diameter 100 mm and 80 mm. Hollow circular section, external diameter 100 mm, internal 80 mm. So only here you see the cross marked is the actual area, internally it is hollow. So D, capital D 100, small d 80. Area is equal to pi by 4 in bracket d raised square minus small d square is equal to pi by 4 in bracket 100 square minus 80 square. So we get the answer 2.83 into 10 raised to 3 mm raised to square. Next is we have to find the solution for Ixxy and Iyy. Next slide. Ixx is equal to Iyy is equal to pi divided by 64 in bracket d raised to 4 minus small d raised to 4. So solving and substituting the value, we get 2.898 into 10 raised to 4. Now we have to find polar moment of inertia, which is given as Ip is equal to Ixx plus Iyy. So by substituting the value, we get the answer Ip is equal to 5.796 into 10 raised to 6. Next slide. Calculate the radius of gyration of a steel pipe having external diameter 22 mm and internal diameter 16 mm. So the capital D is 22 mm, small d is 16 mm. The formula, same formula in the previous problem. Area is equal to pi by 4 in bracket d raised to 4 minus small d raised to 4. So area is equal to pi by 4 in bracket 22 raised to 4 minus 16 raised to 4. Area is 179.07 mm raised to square. Similarly, next Ixx is equal to Iyy is equal to pi divided by 64 in bracket d raised to 4 minus small d raised to 4. Substituting the value, we get Ixx is equal to Iyy eight two 1024. Now we have to find Kxx. Okay, now here Kxx is equal to Kyy, which is equal to under root I divided by A. Substituting value, I 8282.042 divided by 179.07. We get Kxx is equal to Kyy is equal to 6.8. Next slide. Now you have to find moment of inertia and radius of gyration of a hollow rectangular section, external size 300 mm by 200 mm, internal size 250 mm into 150 mm. Here it is hollow in size, and the dimensions are already given in this diagram below. So we have to find Ixx, Iyy, and we have to find radius of gyration. Now we know Ixx is equal to bd cube by 12 minus small bd cube by 12. Similarly, Iyy is equal to db cube by 12 minus small db cube by 12. The value of d, b, small d, small b is given. You substitute the value, you will get Ixx and Iyy. And the formula for polar moment is Ip is equal to Ixx plus Iyy. Next slide. So by substituting the value of B and D, we get Ixx is equal to 1 divided by 12 in bracket 200 into 200 into 300 cube minus 150 into 250 cube. Similarly, Ixx is equal to 254.68 into 10 raised to 6 mm raised to 4. Iyy is equal to in bracket db cube by 12 minus small d small b cube divided by 12. Substituting the value, we get Iyy is equal to 129.69 into 10 raised to 3 into, I repeat, 129.69 into 10 raised to 6. Ip is equal to Ixx plus Iyy. Adding it, we get the answer 384.35 into 10 raised to 6. Now we have to find the radius of gyration. To first find the area, which is equal to BD minus small bd, we get the area 22500 mm square. Kxx is equal to under root Ixx divided by A. Kxx is equal to under root 25469 into 10 raised to 6 divided by 22500, which is equal to 106.39. Similarly, Kyy is equal to under root Iyy divided by A. Kyy is equal to under root 129.69 into 10 raised to 6 divided by 22500, which is equal to 75.9. So K minimum is equal to Kyy is equal to 75.9. Next slide. Now this is the homework problem to solve. For a hollow rectangular section with outer dimension 240 mm into 180 mm and inner dimension 180 mm into 120 mm. Calculate minimum radius of gyration. Second is calculate the polar moment of inertia of a hollow circular section of diameter 170 mm external and 132 mm internal. Also find radius of gyration. Okay, so the capital D here is 170 and the small d is 132. Capital D 170, small d 132. So please solve this problem as your homework. Thank you.